Yes, welcome. Today we're going to be looking at some concepts in our lectures on capacitor. We're going to be looking at electric field in the capacitor, work done in a capacitor, relationship between electric field, potential difference, and distance between parallel plates, and finally the energy stored in a capacitor. We're going to be giving us these relations and equations which are very needed when you're solving problems in capacitor, like when you're doing WAEC, GC, NECO or JAM. These relations are very important. And number one is the electric field in the capacitor, which is simply the measure of the charge intensity, the intensity of the charge in the capacitor. It is simply the force per unit charge, F over Q. The electric field in the capacitor is simply represented as force over quantity of charge, F over Q. And the work done in a capacitor is simply the work done in moving a positive charge from infinity to a particular point in the capacitor. So that work done in moving a positive charge from infinity to a particular point in a capacitor is known as the work done in a capacitor, and it is represented with the relation. The work done is simply QV, and we all know that work done is equal to force times distance. So if we equate QV, which is the work done in moving a positive charge from infinity to a particular point in the capacitor, if we equate it to the normal relation of work done, which is force times distance, we will have that, making F the subject of the formula, force is equal to QV all over D. This relationship is very important. This equation, you need to take note of it. The force needed to move the force on a positive charge, or the force needed to move a positive charge from infinity to a particular point is equal to QV all over D. Very important relation. Need to note it. Now, when we look at the relationship between electric field E, potential difference V, and distance between parallel plates. Distance between parallel plates. I told us that this is the representation of a capacitor. So if we are looking at the voltage between the terminals, potential difference, the electric field inside, and the what distance between the plates, the distance between the two plates, these two plates, the distance. What is the relationship that relates those things together? The potential difference between these 2 points, the electric field, and the distance between the plates. Since E is equal to F over Q, from this one, electric field, we say that is the force intensity of force per charge. And F, as we know from here, is equal to QV over D. Then we can say that E is equal to QV over D, which is the value of force from here, all over Q. So Q cancel Q, will be left with V over D. So in essence, the electric field is simply equal to the potential difference all over the distance. So this electric field between the plates is equal to the potential difference across the terminals of the capacitor all over the distance between the capacitor. Very important relation. Electric field equal to potential difference all over distance. Take note of this. We are going to be using it in subsequent calculations. And finally, we look at the energy stored in a capacitor. How do we calculate the energy stored in a capacitor? Energy stored in a capacitor is simply equal to half 1 over 2 CV squared. Very important formula. If we don't want to use 1 over 2 CV squared, we can use 1 over 2 QV. 1 over 2 QV. Very important. You can use either of these equations to calculate the energy stored in a capacitor, which we are going to be doing in subsequent classes.